we're going to talk about functions and the graphs of functions. Over the course of a couple of videos, you're going to be able to answer the following questions. What is a function? What is domain and range of a function in interval notation given the rule or given the graph? How is it determined if a relationship is a function? Just by looking at the table or the equation. And lastly, how are functions evaluated? So what is a function? A function is like a machine. It's got something that goes in that we call an input, which is your domain, and then it's got something that it crunches out, which is the output or the range. And the output is related somehow to the input, and a rule can be written to describe that relationship. So if you think about this thing being a machine, so there's my machine, and let's erase it so we've got a spot for the output to come out. We're going to put something in, typically it's x or some value, and maybe we're putting it into x squared. That machine's going to do the work and some answer is going to get spit out. What you see on the top of the screen is function notation. So that would be read f of x equals x squared. The fact that it's f of x tells you the function name is f. We might have a g of x. We might have an h of x. There's lots of different names we could give our functions. This here tells you that x is what's going in. And f of x equals x squared, that doesn't look like it's a superscript, but it is, shows you that the function f takes x and squares it. So let's talk through the formal definition of a function. A function is a rule or correspondence that assigns to each element of one set, called the domain, exactly one, that's going to come up later, element of a second set that we call the range. The function can be defined by a set of ordered pairs, a table, a graph, an equation, or even a verbal description. So lots of different formats that a function can take. So how that function is defined is what determines its domain and then ultimately its range. If a function is not limited by the context of the problem, then the domain is assumed to be all real numbers. A lot of times in real-world problems, we know that the values can't be negative. So that is in a situation where the context will limit the values of x. Some domains are limited to values that produce defined values. For example, if I have a function that has a denominator or a function that has a root function, that's going to limit the domain. For example, if I have 1 over x, there's a value that x is not allowed to be. It's not allowed to be 0. So that's going to limit the domain. And we're going to say that x can be everything except 0. And we'll write that in interval notation. We'll say that the domain is everything from negative infinity to 0. Can't be 0, so we use that parentheses rather than a bracket. And then it can be everything from 0 to infinity. So let's look at an example where the domain and the range are given in a table format. So in this example, our domain is just a set of values. The domain is -5, -3, -1, 0, and 3. The range here is going to be -7, -2, 5, and 6. Notice that I don't need to write the -2 twice. So if it wants the range, it just wants a summary of the y values.